Hello, class. I had a student send me this particular question. It is from chapter 3 in our college algebra course. It's asking us to find the axis of symmetry or vertex, determine if that vertex is a max or min, and then find that value, and then graph a function. In this case, a quadratic function, of course. So let's jump in. Uh, Full disclosure, I don't really do part A before I do part B. What I like to do is complete part B first. I like to find my vertex. Not my, let's back up. I am finding my vertex, but to find my vertex, I like to find my axis of symmetry first. And the way I do that is by using x equals the opposite of b over 2a. For this particular problem, and just to teach a little bit, guys, if you don't know, to find your axis of symmetry, if you have a quadratic, all quadratics are symmetric, right? So you have that imaginary line that goes through that quadratic that, cuts it in half. Um, But that line of symmetry is what we call our axis of symmetry. And the way we find that is by, using x equals the opposite of b over 2a. So why is that helpful? Why am I using that? Well, if I were to graph a quadratic and find my axis of symmetry, then what would happen, or what I could find there on that axis of symmetry, is my vertex. That vertex is that lowest or that highest point. It's that extrema. And what happens is that vertex will always fall on your axis of symmetry. So what I like to do is, one, find my axis of symmetry. It's the equation of a vertical line. And once I find that axis of symmetry, then I can find my vertex because it is on that imaginary line. So my axis of symmetry, again, is found by using x equals the opposite of b over 2a. This b in my problem here is 9, so that's the opposite of 9 is -9 over 2 times a, which is 2 times 1. That's -9 over 2. So I know that my axis of symmetry is x equals a -9/2. That's an equation, so I leave the x equals part on there. I'm picky about that because it's a line. But because I have my axis of symmetry, I can now go back and find my vertex. But what this is really my, your vertex is a coordinate, right? So I have -9/2. That's actually my x coordinate for my vertex. So to find that y coordinate, what I could do is take that -9/2 and plug that into the function. And the actual equation is a -9/2 squared plus 9 times a -9/2 plus 18. I don't have a calculator, so you can fast forward through this if you need to. But what I'm going to do is come to the side and actually work this out. So -9/2 squared is going to be 81/4. -9 times 9 is -81/2, and then plus 18. And what I know is I have to have a common denominator. And my common denominator between all of these is going to be 4. My least common multiple is 4. So I'm going to leave that 81/4 the way it is, minus that 81/2. I need to change that denominator to a 4, so I'm going to multiply the top and bottom by 2. So 81 times 2 is going to give me 162 over 4. So that's minus 162 over 4. Then I need to change that 18 to something with a 4 in the denominator. So 18 times 4, 8 times 4 is 32. 3 plus 4 is 7. So that's going to be 72 fourths. Okay, so if I add these two together, that's going to give me a -81/4 plus 72/4. And the difference between 81 and 72 is 9. So that's going to be a -9/4. So what I found is that my vertex is at a -9/2, a -9/4. All right, so I have my vertex, my axis of symmetry. What I also need to find is whether part C says to determine, I don't know why this changes my color without my permission. Part C says determine whether there is a maximum or minimum value and find that value. Guys, you honestly already found that max or min is part of that vertex there, right? So essentially what that part is asking is that vertex a maximum or a minimum? Well, because my A here is greater than 1, when A is greater than 1 or if A is positive, what that tells you is that my quadratic is going to open up. And anytime your quadratic opens up, that means that you will have a minimum value at your vertex. So what part C, or what we just determined, is that because my A is 1, I don't know why I said greater than 1. It should be greater than 0. It's positive. Okay, so if my A is positive, then my quadratic is opening up, and I know that that vertex is a minimum. So what I know is that I have a minimum value of a -9/4 when x is equal to a -9/2. Okay. So that is part C. So I found the value, and part D says to graph. All right, so looking at the graph, what I notice is they have everything broken up into fourths for us, which is super nice. Um, so let's graph our vertex first. My vertex is a -9/2. Um, my vertex was -9/2 and -9/4. So if I were to change that so that we can understand it, 2 goes into 9 4 times, and then 4 goes into 9 2 times. So what we have here really is -4 1/2, 4 1/2, and -2. If I can stay on my line, -2 and 1/4 right there. So that is my vertex. My axis of symmetry, of course, is going right through this -9/2 or -4 1/2. And I need to find um, my another point. And honestly, what I would normally do is graph my y-intercept. But that's not the case here. I need one other point. Um, so there's a few tricks that students use to find points. I don't like using tricks. I want you to understand how the math works. So I'm just going to warn you right now, if there's anything that you don't have that you didn't write down, oops. Okay, if there's anything that you did not write down, pause the video, write it down, because what I'm going to do is I'm going to erase this so I have more room to work things out. I have my important information. I know what my vertex is, but what I need to do is find another point. Now, earlier, when I found my axis of symmetry, the way I found that corresponding y value was by plugging in the x value. You know, my output is my y value. So I may have to play with this just a bit, but let's pick a point somewhere around my vertex. In other words, somewhere near -9/2. Let's plug it into this equation here and let's get a value. Well, I tried to work smart and not hard. With that being said, I know that the further I get away from my vertex, the higher that value is going to be. It's going to grow very quickly. What I also know is that if I plug a fraction in, I'm probably going to get a fraction back out. So what I want to do is I want to pick a whole number that is close to my vertex so that when I plug it in, I don't get a really large value. And because I plug in a whole number, my output will be a whole number. So this is purely preference, but I'm just going to choose a -4. If I plug in a -4, that would give me 16 minus 36 plus 18. And what I do know is 18 is half of 36. So I know that if I combine this, that would give me a -18. 16 minus 18 gives me a -2. -4. Let's see if I can zoom in a bit. -4. I have -2. Oops. -4 is here. Guys, and because my graph is symmetric, what I know is that if -4 has a value of -2, then -5 has a value of -2, guys. And I'm not going to really get any more points here because the way my math lab works, if you can just get another point on that quadratic, it will finish for you. But that is it. So I've graphed it, guys, and if you have any questions concerning this, shoot me an email.